Hi guys, welcome back to Matplotlib versus YouTube channel where curiosity meets the code. Today we'll be discussing about how to create a lunar orbit animation. But before that, we'll be checking the packages pre-installed in my system. So the first command that I'm going to execute in command prompt is pip list, where you can see all the packages with the versions. So you can give a look about what package is what version and update it accordingly. So you can take a look onto your packages. If not installed, please do install it. You can just Google how to install and there will be a command for that to execute in command prompt. Another command to check for all these is pip freeze, which gives a similar output where packages with the version will be mentioned. So let's start with the coding part, starting with importing the necessary libraries, starting with importing NumPy as NP, which is used for numerical operations in Python, and we are importing matplotlib.pyplot as PLT, which is used for creating static, interactive, and animated visualizations in Python, and from matplotlib.animation import fun animation, which is used for creating animation by repeatedly calling a function to update the figure. Next, we have the constants where we have Earth radius as given as 9771 and Moon radius as 1737 and Moon distance is 38,000, sorry, 3,84,400 and rotation speed is 27.3, which is the degree, and then 24 hours into 3,600. Then we have to create a figure and axis. So for that we have a couple of codes which includes a figure dot comma ax is equal to plot dot subplot. This creates a figure and a single subplot with matplotlib, and we have ax dot set aspect equal comma box. This sets the aspect ratio so that the x and y axis are scaled equally, and this prevents the circle representing the earth from the appearing the elliptical. And we have ax dot set x limb minus moon distance minus moon radius minus 1000 comma moon distance plus moon radius plus 1000, and same goes for ax dot set y limb. This is minus moon distance minus moon radius minus 8000 comma moon distance plus moon radius plus 1000. 10,000. So we are setting the x and y limits of the plot to include enough space around the earth and the moon. And later we have ax dot set yx label and y label. So here you can see we are setting the x label to distance in kilometer and y label to distance in kilometer, and we have ax dot set title rotation of the moon around the earth. We are setting the labels for x and y axis and a title for the plot. Next, we have to plot the Earth and the Moon. So for that, we have Earth circle is equal to PLT circle 0, 0, Earth radius, color is blue and label is Earth. This creates a circle to represents the Earth position in the origin 0, 0. And then we have Moon circle is equal to AX dot plot 0, and then colors as given as orange, market size as 45, labeling at moon, and we have moon orbit is equal to ax dot plot color red and line style as dash dash and label as moon orbit. So here moon circle, this initializes the moon maker as an empty plot, and we have moon orbit initializes the plot of the moon orbit as an empty dash line. So next we have to add the earth to the plot. So we have ax dot add artist earth circle. This adds the earth circle to the axis as an artist object. Moving on, we have a function to initialize the plot. So we are starting with def int moon circle dot set data to empty list, and then moon orbit set to again empty list. Return moon circle comma moon orbit. This defines the initialization function for fun C animation. This sets up the plot for animation by clearing the previous data. And the two attributes that are returned from this function will be moon circle and moon orbit. Moving on to the next function to update the plot, we have def update frame. This is, defines the update function, which is fancy animation cost. This function computes a new position of the moon and updates the plot. And we have angle is equal to 2 into np dot pi into frame slash rotation period. This calculates the angle of the rotation of the moon around the earth of the current frame. And we have moon x moon y is equal to moon distance into np dot cos angle, and moon y is equal to moon distance into np dot sine angle. This computes x and y coordinates of the moon based on the current angle. And we have moon circle dot set data moon x comma moon y. This updates the moon position in the plot. And later we have orbit x and orbit y. So orbit x is equal to moon distance into np dot cos a for a in np dot line space 0 comma 2 into np dot pi comma 100, and same goes with the orbit y, except the instead of cos, we have the sine formula. This calculates an x and y coordinate for 100 points along the circle to represent the orbit of the moon. And we have moon orbit dot set data orbit x and orbit y. This sets the data of the moon's orbit. And we have return moon circle comma moon orbit. This returns the updated moon and the orbit of the animation. Next, we have ANI is equal to func animation fig, comma update frames np dot arrange 0 comma rotation period 3600, and we have int function is equal to int and delete we have true. So this creates an animation object specifying the figure update function, frames and initialization, and we have delete is equal to true. This enables optimized drawing. And we have ax.legend. This displays a legend on the plot, and we have plt.show. This shows the plot with the animation. So let's quickly see the output of the program. So as usual, I'm going to go where the folder is stored, the .py file, copy the name of the .py file, open the command prompt in the same window. We have python space file name .py, and you can see the earth as a blue circle in the middle, and the moon's orbit as dash in red, and the moon is circling around the earth. Thank you so much for watching. If you have learned something from this video, please do like, share, and comment down below. Thank you.